Morning, everyone. My name is Patrick Malou, and I lead public sector marketing for AWS in Middle East and Africa. The session right now is about achieving your department objectives, providing better citizen services at lower costs by Fabrizio, Pappalardo, Partner Manager, AWS. Thank you.
Thank you, Patrick. Good morning, everyone. I think I should have decided for a different title, a little bit catchier, so that I would have been able to attract more of you today. But the session is going to be recorded, so hopefully I'll be reaching a wider audience later on as well. But thank you for being here. The objective of today is to share with you how a public administration can provide better services to citizens at lower costs. We have seen a few examples before coming from the UK on how budget reductions have impacted the decision-making process of how to invest in technology. And I want to provide you today with a very quick agenda where I want to drive you through what makes AWS unique in terms of proposition in this industry. How do we understand and compare total cost of ownership, which is not always an easy job, comparing the existing physical on-prem infrastructure with the total cost of ownership or total cost of operation of a cloud infrastructure. And then I'll give you some hints on how you can try, at least, to put on the same equation both things, and how you can optimize your cost while you run your infrastructure on AWS. And then, better than anything else, I want to share with you the story, a real-life story of Comune di Cagliari, which is a municipality down in Italy, that has been adopting AWS services and has been able to deliver incredible services to their citizens. So, why AWS? AWS has 12 years experience in cloud, and these 12 years of experience cannot really be compressed. The amount of customers that we serve are in the range of more than 1 million customers, and this allows us to really challenge ourselves with really many different use cases. Many of the use cases that you've seen before a use case for a hybrid cloud with VMware. We have really seen most of them. The ability to innovate in our portfolio of services has allowed us to introduce more than 100 services in our cloud platform. 100 services that are related not just to virtual machines or computing, storage, and networking, but really services that go beyond the basic infrastructure, services that allow you to use managed databases, services that allow you to have scalable big data platforms, services for IoT, machine learning, artificial intelligence, and a marketplace with 4,200 different ISV offerings. Getting part of AWS means entering a network of a global infrastructure that today is available through 18 different regions with 54 availability zones and 114 edge locations. And it means adopting a pricing philosophy that has brought us to reduce prices 65 times over the course of the previous 12 years. So it's a logic that it takes time to get adopted. But it's a logic that once customers get exposed, they tend to love it. So the difference between the traditional infrastructure that you've been using, which is great infrastructure that has given you the ability to truly deliver services to your citizens today, is that you today manage equipment, acquire equipment, sign contracts, you use operational resources and spend a lot of dollars in keeping this infrastructure alive. There is nothing wrong with it. It has been great. That has been the world until today. But now we also have an alternative which is basically no longer invest for what you don't know yet, if you will use it, no investment upfronts, getting the ability to use the services that are there. They're already to be used. Services in terms of computing, storage, networking, but all the software stack that I've been briefly describing before. You want to run an IoT project? The IoT infrastructure is already there. It takes 2 hours for the VMware team before to put in place a full infrastructure. It takes a few minutes sometimes to start deploying some services on the AWS cloud infrastructure. So the beauty is that you can finally scale up and down based on your business needs and the consumption patterns over the course of the year. And all of this of course, it might sound simple. It's less simple than it is. It's all provided through a good level of abstraction through an API and a self-service interface through our console. So what makes AWS stand apart is the global footprint and architecture that we have available. When we talk about regions, we are talking currently about 18 regions. Within a region, we are having usually a cluster of data centers. A region at AWS is not one data center. It's a cluster of data centers grouped in availability zones, usually 2 or 3 in every region. Why availability zones? With multiple data centers that are on different floodplains, different earthquake risk planes, and basically it's something that allows you to deploy highly reliable infrastructures in a single region. And why different regions? First of all, to give you the ability to have a global reach and to give you the chance to be compliant with different legislations around the world. Wherever you have to be, we might have a region that allows you to be in an area that is compliant with certain regulation, which is closer to your customers. And when there is not a region closer to your customers, there is for sure one of the 114 CDN points, edge locations that we have around the world to accelerate delivery of our services. So this is what it is unique of AWS and what gives you the tools to fully develop the services on our cloud platform. So let's get into total cost of ownership. Usually when we talk about total cost of ownership, we tend to put together the cost of acquiring and operating an infrastructure so that we can create a comparison between an end-to-end on-premise infrastructure with AWS. Let me tell you why is it difficult to truly compare TCO, the usual way, the old way with AWS. Because when we compare typical TCO considerations, we tend to put the server cost, the storage cost, the network cost, sometimes labor cost. Sometimes we forget to add labor cost. But we tend to forget a lot of the right side part of this slide. Sometimes when I talk to customers, they don't take into account that facilities have a cost. In the data center side, where they have their data centers, sometimes they have a man who takes care of the garden, and they don't take care of that salary when they factor the total cost of ownership of their existing infrastructure. In many cases, power and cooling is not taken into account because simply these budgets are sitting somewhere else within the organization. So it's not always easy. But most of all, what it is not always easy to compare is the business value of an AWS infrastructure. Having services ready to be deployed in real time, having the ability to take advantage of 100 and more services that are there to be used, it gives a competitive advantage and it democratizes access to IT services. This is not always taken into account, but it's what makes AWS very different to compare to a traditional on-premise infrastructure. So when we do infrastructure comparison, we usually say, okay, how much does it cost to buy a server and some storage? This is the very basic that I usually meet every day. And how much does it cost? The equivalent virtual server on AWS. But this doesn't take into account the cost of operating of the resources that you allocate, the capacity planning that you have to do when you really think of deploying a large data center. You don't take into account the financial benefits of innovation that AWS allows you to fully take advantage of. And many of the other costs are not really taken into account. So why is this not taken into account, and why in on-premise infrastructure we do have some capacity planning challenges that basically bring an inefficiency in your physical infrastructure? Well, different studies, but you probably, if you look at yourself, you probably know it, most of data centers are underutilized. Probably less than 50% utilized. It's nothing wrong with what you've done, but this is capacity planning in the traditional world. Why? Because whenever you plan for capacity in your data centers, you never plan, first of all, for the existing capacity that you have. You usually plan to a 3 to 5 years capacity, and you have to design a data center which is capable to handle the spiky, fluctuating demands that you might receive from your users that maybe are different during the hours of the day, or days of the week, or weeks of the month, or months of the year. So if you don't plan your data center capacity for that moment of peak, you might not be able to serve your users. So you have to buy a very big car for a 7-seaters or a 10-seaters for those 2 times of the year when you take your kids' friends with you at the party, which is not exactly the best way to use your resources and your citizen resources. So when you start thinking about a total cost of ownership comparison, start thinking about how you run capacity planning today. What it is your average server utilization. I will give you some hints later on, because once you start using these parameters, we usually tend to tell you, don't size and don't create a cloud infrastructure that reflects exactly the physical infrastructure that you have. Because you have already created an inefficient infrastructure on-premise, don't bring that inefficiency on the cloud. Start on demand, start seeing how you consume resources, and then only after some time you will truly be able to understand what is your average consumption. So take into account operations, take into account power and cooling billings. It doesn't matter where these billings are actually sitting, if it's under another department or are not under your responsibility. In the end, it's something that our citizens are paying for. And if and when you move to AWS, I will show you how you can optimize your usage and take advantage of the multiple different tools that we have to make efficient decisions on our cloud platform. So when we think about TCO in AWS, you first of all need to start thinking that you don't need to provision anything up front. You can simply pay for what you use. Start on demand, and if you consume, you pay. If you don't consume, you don't pay. Think about how we manage the economies of scale of this hyperscale infrastructure of 18 regions and 54 availability zones around the world. This allows us to have a very efficient infrastructure, but also allows us to continuously lower cost, 65 times over the course of the past 12 years. And we also have different pricing models that allow you to really find the right model for your business, or combine different pricing models within your purchasing options so that you are not locked into anything. You can use on demand, reserve, spot, and I'll give you some more ideas of how these different methodologies work. So this is the typical capacity usage of a data center. Of course, typical, it depends. It's one that we have taken into account, where there is different usage of IT resources based on different days of the week. Sundays and Saturdays are very low, and the 5 working days are actually very high. So instead of planning for an infrastructure that is designed exactly like you designed your physical infrastructure, our suggestion is to use on-demand and auto-scaling, so that you will be able to have an elastic infrastructure that will cope with the demand of your users. It can become bigger or smaller based on the days of the week. If there is demand, you can add extra instances, extra computing resources to handle with that demand. If you don't have that demand, an auto-scaling group can scale down and allow you to just use the amount of resources that are needed at that point in time. This brings a great efficiency within your usage pattern. It can help you in really designing an infrastructure that is tailored to your needs and that adapts to you over the course of the year. So this is the model that we tend to use in order to bring economies of scale at your service. We tend to bring more customers on our platform, that bring more usage, that allow us to buy more and have a stronger negotiational power with our suppliers, and that allows us to achieve better economies of scale that we usually tend to use it to give back that advantage to our customers. So when it comes to pricing models, you have 3 pricing models on AWS as far as computing resources are concerned. You can buy on demand, which means you don't commit anything. So we don't want you to buy anything, actually. You just open your account and you start using instances as much as you need. You create elasticity, auto-scaling groups, and resources are added or removed based on the demand that you see from your users over the course of time. But once you understand that you have a certain recurring usage, and you understand that there is an average usage pattern that you see, we can give you an economic incentive if you allow us to do a better capacity planning for our own data centers. If you reserve your instances and you tell us, I need this type of instance for a certain amount of time, 1 or 3 years, we can give you an economic advantage on acquiring that instance if you commit to buy and use that instance. Or, if there are specific workloads that can really take advantage of our spot instances, which is basically you bid for unused capacity in our regions, and you say, you know what, maybe AWS has some of that inefficiency that I've been describing before. During certain moments of the day, or the year, or the month, there are lower usage patterns on their own data centers, so maybe AWS is willing to sell that capacity at a more competitive price. So you go and bid for a price that is usually the price that you want to pay. If the market demand for that type of instance will go at your bidding price, we will sell that instance to you at a competitive price, extremely competitive price. So this to do what? To basically allow you to create a mixed consumption model where you buy for average capacity and reserve instances for your bottom line of the average capacity. You use on-demand instances for every peak that you have to handle, so that you don't commit to inefficient infrastructure. And you can use a spot for specific workloads that will not require committed time and will be able to be shut down within 2 minutes after we tell you. So, what does reserved instances mean? It means that if you are able to tell us that you can commit in using a specific type of instance for 1 or 3 years, we can give you up to 75% savings compared to the on-demand pricing. Of course, these savings depend for how long you commit. If you pay upfront, non-upfront, partially upfront, there are different methodologies, but this reserved instance methodology can be applied not just to EC2 computing, but also to database capacity, that managed databases, relational database services, to DynamoDB, Redshift, and Elastic Cache. So you can commit to use this and get an extremely competitive pricing on the reserved instance compared to the on-demand. This is an example of a M4 large instance that you can buy at 1 year, no upfront, partial upfront, or completely upfront, and you go from 32 to 43% savings on a reserved instance price compared to on-demand. So almost 50% if you're able to commit for 1 year on a certain type of reserved instance. The spot instances, as I said, it's a unique offering of our unused capacity in our regions, allows you to bid on the spare computing capacity and get up to 90% off the normal on-demand price. So you can use it for applications that usually run batch workloads. It's great for customers who have been using dev test, customers who have been able to run applications that have flexible start and end times, but most of all, applications that are usually able to be shut down with 2 minutes notice. So if you can run this type of applications, you can take advantage of spot appliances. So look at the workloads that you have in your data centers. You probably have some workloads that are perfect for reserved instance. Sometimes you combine reserved with on-demand, but you might also have room for spot instances. So if you combine the 3 models, you can achieve an extremely competitive pricing for the cloud services that you're using. So with spot, the rules are very simple. You bid at a certain price. When the market price gets to your bidding price, you get the instance assigned. You will never pay more than your bid. So if the market price gets at your bidding price, you get the instance and you use it. But as soon as the market price, it means that there is a higher demand for that instance and someone else is able to pay a higher price than the one you pay, we give you 2 minutes to wrap up your work and we'll shut down the instance. So the instance will come back to you when the market price will go down again at your bidding price. So that's the beauty of the 3 different models. But the other example on how you can optimize your cost on the cloud, the first is mix the 3 consumption models, on demand, reserved, and spot. The second is there is more opportunity to save money on storage, on S3. This is the example on how S3 pricing is steered. The more your needs grow, the higher the incentive it is for you. So you go from 24 cents per gigabyte per month on the first 50 terabytes of consumption that you have to 22 cents per gigabyte per month over 500 terabytes. So, and if you grow larger, let's talk about it. So when we talk about cost optimization in AWS, we usually have this path. You start from on-premise. The first step is lift and shift. Take everything you had in your data center and move it on AWS. The first step, it's actually very candidly the most expensive moment in your cloud transition because you have your physical infrastructure on-prem alive and kicking and your cloud infrastructure running at the same time. So you pay for 2 pieces of infrastructure in the first step, and usually in the first step, the lift and shift, you bring part of the inefficiency that you have in your physical data centers on the cloud. Why? Because you are afraid what happens if the server I bring on your cloud is smaller than the one I have in my data center. But sometimes you have even over-provisioned not your just data center, but the entire server community. You have been buying a server not for today, for the next 3 to 5 years. And you bring that on the cloud. But that's fine, there's nothing wrong with it. It's part of the path. So you come onto the cloud, you start with on-demand, you understand, because we give you full control and full metrics to control and see how you're using each and individual server, each and every CPU, every memory, every network interface. And you will be able to understand that, for example, you don't need these big servers in the cloud. You can shrink down your servers and do what we call the instance right sizing. You can use better elasticity. You start using the auto-scaling group and the elastic load balancer to distribute traffic among auto-scaling groups and allow you to save money on scaling down instances and having an elastic infrastructure that becomes more efficient than the one you had before. You can go through storage optimization and get to the first stage of optimized lift and shift. This is just the first part of the journey. The journey becomes even more interesting when you start adopting the managed services, the managed databases. You start introducing a serverless architecture. And I'll give you a hint of what serverless and Lambda is. It basically means that you don't even need to provision a server. You simply take your code, you give us your code, we run your code, and you don't care about the entire stack that is below your code. And it's something that can scale up and down, it's highly reliable, and you don't pay for idle capacity. A server, probably 50% of the time, the application in the server is not even running. Why pay for it? The hypervisor is on, the operating system is on, you don't even care about that. And we support most of the available computing languages in serverless. And then you can adopt managed services from one of the many AWS partners that can take away the entire complexity of running this infrastructure. And as an ultimate step, you can re-platform your applications to truly become cloud-native applications that take advantage of the cloud and offer you an extremely competitive approach to what you've been seeing until today. And I'll give you the example later on with the community gallery. So the 5 pillars of cost optimization for us is find the right instance size for your business. You have inefficient data centers with inefficient computing resources. You haven't done anything wrong, but that's the way we were working in the past. Get ready to handle the future demand. In the cloud, when the future will be there, you will pay for it, but you don't pay upfront. Then make sure that you can increase elasticity. Use the scalability of the cloud, auto scaling, elastic load balancing, and make sure that your infrastructure can become bigger or smaller depending on the amount of users and transactions you have to handle. Pick the right pricing model, or mix the 3 different pricing models: on demand, reserved, and spot, and make sure that you choose the right storage class. If there is data that you can access very rarely, it doesn't need to buy a frequent access storage class for that data and pay for a higher price. And of course, the methodology is to measure, monitor, control, and adapt this model over time, continuously. And we give you the tool, ourselves and our partners that are present on the marketplace, to run this analysis, because our objective is not to let you spend more, but it's to optimize your cost. If we optimize your cost, you will do more things with the cloud. And let me say, the higher investment will come naturally and spontaneously. So, right-sizing instances means a lot of smaller instances are better than bigger instances. Let me give you an example. This is an example of 25, 29 M4 large instances compared to 59 T2 medium instances. As you can see, the pricing per month is more competitive if you buy smaller instances than bigger instances. The overall computing capacity is the same, but if you've been able to use better scaling mechanisms and right tailoring mechanisms, you can optimize your cost. So smaller is better than bigger, usually on the cloud. Match your storage usage to the right storage classes. So S3 is great, it's our SAN-based solution, but you might need a lot of direct attached storage, like elastic block storage. So try to understand which data has to go where. Or some data might stay at home, and you might use an AWS storage gateway, or an Amazon Elastic File System. Or if you really needed to access data infrequently and rarely, or use it, or use storage for backup purposes, you can use Glacier. Or if you really need to distribute contents globally and be able to deliver content very fast everywhere in the world, you might use CloudFront, our CDN. So even here, you can mix and match several different types of storage services to your specific need. You don't just have a virtual server in the cloud. You got something more, it will require some time and study to combine the different services together, but this is how you optimize your usage on AWS. And then serverless. We have 2 services that are serverless today. The first is Lambda. Lambda is fully available. It's basically a service where you don't need to manage any server. It scales up and down automatically, so you don't even care about auto scaling, elastic load balancing. It's highly available, guaranteed by ourselves, and doesn't provide you any cost for idle capacity. What it is, you give us a piece of code and we can run that code. When do we run that code? We run that code when an event will trigger. You define what sort of event. When an event happens in our cloud, someone writes something in a database, someone writes something on an S3 bucket, that can trigger an event. You can intercept that event with a Lambda function, and you can put a piece of code in that Lambda function to read what was written, apply some form of logic, take some form of decision, and pay just for the amount of milliseconds of code that is running, in blocks of 100 milliseconds, of course. So the beauty is that you don't even care of what servers, what operating systems. And the other serverless service that we have introduced recently at reInvent is Aurora Serverless. Think about your database. If you didn't need to worry about provisioning capacity, the DB engine, the DB administration, all of that can be serverless. You just run query, write, read on your database, and pay just for the amount of transactions that you have in your database. So this is the last step of re-platforming for AWS and take fully advantage of the cloud. It's not even lift and shift. You don't even care about the hypervisor or the physical infrastructure that is running below. So the mantra is always measure, monitor, and improve. It's a constant job that you have to run. We give you the tools, and the source of single truth within AWS, it's CloudWatch. We track everything that happens within your cloud infrastructure, create detailed logs, even detailed logs on a per minute basis, that allow you to monitor the resources, set the alarms, monitor custom metrics. You define your own metrics. If the ones we've got there are not enough, you define what you want to measure. And with what you measure, you can monitor, react, see graphically what results you are achieving, and basically take decisions, either using your own tools or our partner tools that take these logs and can provide you some rational information with it. But I think that the best stories are the ones that customers tell us. And I want to tell you the story of our customer, the Comune di Cagliari. It's a municipality in the beautiful Sardinian island that in 2016 used a lot of the technologies that I've been showing before to deliver election results using the cloud. So I should probably change my accent into a Sardinian accent, but I'm not very good with the English, imagine the Sardinian. So this is where they live. Imagine spending time in an IT environment is not really nice, but the IT team is a fantastic team. Because instead of just joining the beauty of their city, it's a metropolitan area with almost 500,000 people, with 17 municipalities. And what they usually enjoy, it's a beautiful environment where over time they've built two data centers, a primary site and a secondary site, with full state-of-the-art technologies, including some of the technologies that our partners have been selling. These data centers are great, but the challenge that they've always had over the past few years was that they were never able to handle a spike in demand when elections came. Delivering election results for them was a key challenge, because citizens were really interested in understanding in real time what were the trends in election results, and their previous infrastructures were always crashing. So how do we handle this? So they were very smart, because they had, an important project goal, which was to provide finally a very fluent navigation of the election results in real time. But the challenges were that they never used the cloud before. This was 2016, so it's already 2 years ago. And cloud requires a form of cultural change within each and every one of you. It's not about being afraid, it's about taking advantage of it. And they only had 3 weeks. So when we talk about agility, flexibility, think about this case, 3 weeks to create something to deliver election results to their citizens. And 3 weeks to do development, deployment, testing, everything, basically. Not just implementing a physical infrastructure. Probably in 3 weeks you don't even provision a server. You don't even buy and get a server in your facilities. So what they did, well, they created an hybrid architecture where they basically exposed the data that were collected by the different voting polls site into their data centers. They collected this data, they put this data in their data centers, and they were exposing this data through JSON and XML APIs to what? To a Lambda function. Not to a virtual machine running a piece of software, but to a Lambda function that from an AWS cloud was reading this data in the customer data center, a hybrid configuration, and reading this data, the Lambda function generated static web pages once every 3 minutes, where in 2 different regions, in Frankfurt and Germany and Ireland, they were recreating their website, the front end of their website, every 3 minutes in 2 regions, and they used Route 53, our DNS, and our CDN to provide them even faster access with CloudFront. And what they did, basically, it's this architecture. So, a Lambda function reading from their open data interfaces in their data centers, creating static pages that were put, HTML pages with data that were put into S3 buckets. S3 buckets that were supplying their content to CloudFront that allowed them to supply the service to the millions of requests that they received. So, when I'm talking about the huge traffic peak, we are talking about almost 7.3 million requests. So 450,000 citizens probably they connected multiple times during the day to connect, to check the election results in real time. And the beauty is that they've been able to handle up to 200 requests per second in peak moments. Imagine what sort of infrastructure would have been needed to handle 200 requests per second. And they say on the chip, let me see if the animation works, because I might probably ask, and I wanted to do a little contest to the one that gets closer to the cost, to the total cost of this service, the AWS cost of this service to the customer. I'll give him a nice t-shirt from the summit. So, can some of you throw a number? How much all of these costed in terms of AWS infrastructure usage to deliver this service? Throw a number. 5,000. That could have been a good price. Still very competitive, but the reality was 125 euros. You see? Pardon? Well, you should have you should have guessed it right, and you were the only one. But I'll give you the T-shirt anyway, because you were fun attending the contest. So this is what we mean with cost optimization, then delivering better services to your citizens. What happened is that after this experience, the Comune di Cagliari, these are not my words, these are Piero Orofino, the IT manager of the Comune di Cagliari's words. They never invested in their physical data center any longer. They embarked into a series of new projects using serverless IoT for their citizens. And they are now adopting the cloud to truly innovate the way they interact with their citizens. Of course, spending intelligently their IT budget for innovation and not necessarily to keep the engine running. So that's just an example, but in summary, what I want to share is that cloud is the new normal. It has been around for 12 years. If you really want to rely on someone who can help you implement any use case you might have in your world, that someone might be AWS, with the 12 years of experience that cannot be compressed. Cost control and containment is a key attribute of cloud computing. So you don't need to pay for anything up front. Scalability, elasticity is within the nature of our cloud platform. If you adopt services like serverless, you can even forget about the complexity of running the infrastructure overall. And the key to achieve these benefits is to use our partners. Because we didn't mention the partner, but who developed the code, who developed that architecture for Comune di Cagliari was an APN partner based in Sardinia that in 3 weeks developed the code, managed to put in place that infrastructure, opened the AWS accounts in Ireland and in Frankfurt, managed to put the game together and deliver the result. So find the right partner for your use case. We have hundreds of partners that can help you in different stages of your cloud maturity. And cost optimization usually starts with designing the right infrastructure with your specific needs. So you can bring your workloads that you have today on the cloud, which is great, which is fine. That is lift and shift. But with that, you will bring some inefficiency in your cloud. Start your cost optimization journey and start for everything you're thinking if you even need to provision a server. Serverless might be there for you. Lambda might be there for you. Aurora serverless might be there for you. Or many of the managed services that we offer are there for you. Any database you have, we support it on our cloud through RDS as a managed database. You can bring your own licenses, you can buy licenses through AWS and manage a database through a managed service offered by AWS. So think about the right infrastructure that is useful for your specific needs. Some of the past principles are still alive, some of them might not necessarily be useful in this new world. So I really thank you for your time, and I wish you a great rest of the day, and I think we now have the keynote session in the next room. Thank you.